Hi friends, welcome to MathsConcepts. In this video, we are going to learn about closure property for whole numbers. When we talk about closure property, we actually check if we perform any mathematical operation like addition, subtraction, multiplication, division on two whole numbers, whether the result is going to be a whole number or not. So first we will see closure property for addition. Let's consider this is a pot of whole numbers. It contains only whole numbers. We know what are whole numbers. Set of natural numbers along with 0 is set of whole numbers, that is numbers 0 and above are all whole numbers. This pot contains only whole numbers. Let's consider one simple example, that is 3 plus 4 equal to 7. We know that 3 is a whole number, 4 is a whole number, and the result, that is 7, is also a whole number. We have also learned in our last video about addition of two whole numbers. When we add two whole numbers, we always move towards right on the number line, and the arrow towards right indicates that this number line can be extended up to any number on the right side. Okay, which means addition of two whole numbers is always going to be a whole number. Few more examples to explain this are 11 plus 7 equal to 18, 46 plus 5 equal to 51, 54 plus 22 is 76. All these three are whole numbers. You can also try few more examples on your own and you will know that addition of two whole numbers is always a whole number. So we can say that whole numbers are closed under addition. What does it mean? It means that addition of two whole numbers is always going to be within the set of whole numbers. It will never go out of whole numbers. Okay. Alright, let's check this property for multiplication. We know that multiplication is repetitive addition. So let's take one simple example here. 2 into 3 equal to 6, and it can be shown on number line like this: 2 units 3 times on the number line. As we said, we move towards right on the number line for addition. Similarly, we move towards right on the number line for multiplication as well, as multiplication is repetitive addition. And that's why, since this number line is extendable towards right up to any point, up to any number, that's why the multiplication of two whole numbers is always going to be a whole number. Few more examples are 4 into 2 equal to 8, 3 into 6 equal to 18, 7 into 8 equal to 56. All these are whole numbers. You can try few more examples on your own, and again you will know that multiplication of two whole numbers is always a whole number. So we can say that whole numbers are closed under multiplication as well. Okay, which means the result is always going to be within the set of whole numbers. It will not go out. Okay, now the next closure property is for subtraction. Let's take one example. 7 minus 4 equal to 3, which is a whole number. Fair enough, we know that 7 is whole number, 4 is whole number, and 3 is also whole number. On number line, we know that for subtraction we move towards left. So let's consider another example, that is 3 minus 4, and what would be the answer? Of course, if we move 4 places towards left on the number line, we are going out of this number line and beyond 0 towards left. The answer would be minus 1, which comes into integer. It is not a whole number. Okay, so when I subtract 3 from 4, answer will be 1, which will not be part of this pot and it will go out. Okay, it will not be part of whole numbers. That's why we are taking out the result of subtraction of 3 and 4 outside the pot. Few more examples are 22 minus 76, again less than 0. 3 is whole number, 4 is whole number, 22 is also whole number, 76 is also a whole number. Subtraction of two whole numbers may not always be a whole number. It is whole number in this first case, but in second and third case, it is not a whole number. It may be a whole number, it may not be a whole number, which means subtraction of two whole numbers is not always a whole number. Okay, and that's why we say that whole numbers are not closed under subtraction, which means the result of subtraction of two whole numbers can be outside the set of whole numbers. There is always place for the result to go out. Okay, this is just an analogy. Now, closure property for division. We know that division is repetitive subtraction. Let's see few examples. 6 divided by 3 equal to 2. It is a whole number. We know 6 is whole number, 3 is whole number, and 2 is also a whole number. Here I have divided 6 into 3 equal parts of 2 units each on the number line. Now, if I take another example, say 7 divided by 2, 7 is a whole number, 2 is a whole number, but resulting answer 3.5, is it a whole number? No, it's not a whole number. 3.5 will be somewhere here on the number line. It is not a whole number. Only whole numbers are 0, 1, 2, 3, 4, 5, 6, 7 and so on. So fractions or decimals are not part of whole numbers. So the result of 7 divided by 2, that is 3.5, will not be in the pot and it will go out. Okay. Now one more example I can show you is 5 divided by 10, which is half, that is 0.5. Again, it's not a whole number. Fractions, decimals, not part of whole numbers. And we can say that division of two whole numbers is not always a whole number. It can be a whole number, it may be a whole number, it may not be a whole number. Okay, and that's why whole numbers are not closed under division, which means the result of division can be outside the set of whole numbers. Okay, so this was all about closure property of all operations, closure property for all operations for whole numbers. I hope you understood the concept well. Thank you for watching this video. Don't forget to subscribe to our channel for more videos. Thank you. Bye bye.